Defining rational numbers. So defining rational numbers. And if you look at the I can statements, you'll see that a lot of what you're supposed to get out of this chapter really doesn't have tons to do with rational numbers. But we are going to define rational numbers kind of as we go. First thing is a repeat from what you did in Math 7, is it's converting. I found a lot of people didn't master it before. Converting decimals to fractions. So converting decimals to fractions. If you found, as we're going through this, if you're like, I remember all of this stuff, feel free to skip writing it down. But for a lot of people, I found it's a good review. You're going to have two types of decimals you want to convert to fractions. We're going to have decimals that stop. They refer to them as like terminating decimals, or decimals that are repeating. So I'm going to say letter A is terminating. If you, I don't know how much you watch like old movies, but like Arnold Schwarzenegger was like the Terminator, and then the Terminator 2. So Terminator is like to stop, or to terminate is to stop, and there's this robot guy that they're trying to kill. I don't remember it insanely well. But if you have a decimal that stops, so 0.2, 0.37, 0.61849, but if you have something with a limited number of decimal points, here's the key. Is you put it over, I wasn't sure exactly how to write it, so I'm going to do like 100 ... where the number of zeros equals number of decimal places. Well, and simplify, maybe I should say. But it depends on your number. And here's what I mean by that. So if I were to take and do like an example, 0.1 is going to be 1 over 10, right? 0.1, you agree that's 1/10? So try to start with one that hopefully you know you can do in your head. But 0.1 has one decimal point, so you put it over a 1 with just one zero. Where if instead I had like a 0.235, now we have how many decimal points? We have 3, because there's the 2, the 3, and the 5. So now I write 235 over a 1 with 3 zeros. Because I had 3 numbers after the decimal, I have to have 3 zeros after the 1. And if you try to think about how would you actually say the 0.235, technically it's 235 thousandths. So if you remember back to earlier this year, I think we did tenths place, hundredths place, thousandth place. So that 5 is in the thousandths place. If instead we had a number like 0.3 repeating, or 0.62, 62, 62, or the 62 is repeating, I'm going to call that letter B, and that would be a repeating. So repeating, or you could even write repeating decimal if you wanted to. Instead of putting it over like a 10, 100, 1,000, a 10,000, now we're going to be putting it over nines. So I'm going to say put over nines. So over a 9 or 99 or 999. And it's going to be similar in that where the number of nines equals the number of repeated values, or number of repeated numbers. So if we were to have 0.3 repeating, it's just 3 is the only number that's repeated, right? So we do the 3 over just 1, 9, because it's just 3. 3 is repeated over and over again. And then we should go through and reduce that and say, okay, that's the same as 1/3. But if I had a 0.23 repeating, 0.23 repeating, or 0.23, 23, 23, 23 on forever, is going to be 23 over, someone want to take a stab? 99. Very nicely done. So 23 over 99. If you had a 0.2571, then it would be 2,571 over exactly, 9,999. So okay, how many digits are repeating? Put it over that many nines. We okay for converting decimals to fractions? And all right. Now we can actually jump into kind of the point of the section, which is going to be rational numbers. So that's my Roman numeral 2. So rational numbers. To avoid like rewriting the whole term rational numbers, I'm just going to kind of underline it, put a little arrow. When we're talking about a rational number, I'm going to say like two things are going to be true about it. So 1 and 2. First thing, it's going to include numbers that can be written as a fraction. So numbers that can be written as a fraction. It includes decimals that, because we just looked at, well, how do we write these decimals as fractions? So it includes decimals that terminate. And you're welcome to write stop in there if that makes more sense. Maybe I'll write it too. That terminate or stop, you could say. Or repeat. So you're right. It includes pretty much everything. So examples would include things like 5, because 5 is the same as 5 over 1. It includes things that terminate or stop, because if I had like a 0.23, that's going to be a rational number because that's the same as 23 over 100. It would include things that repeat, because if I had a 0.67 repeating, that's the same as 67 over 99. Nice. So it includes numbers like those. The very last thing gets into what we've had at the beginning of a couple of those RTI tests, and it's like comparing numbers. And I've noticed that they seem to always, towards the very beginning, say, here's 5 numbers, put them in order. And that's kind of what we're hitting in this section. So I'm going to do an A and a B. So the A is going to be as fractions. So how do you compare a couple fractions? And the book gives this bit of advice. They say change to common denominators. So first way to do it is give them common denominators. And I'll quick do an example of that. So let's say we have 2/3, bless you, 3/4, and 3/5. And we're trying to write those in order from smallest to largest. So maybe, so write smallest to largest. Say those are our instructions. If it doesn't matter if you have the smallest common denominator or just a common denominator, you could take and multiply all 3 denominators. So if I would do the 3 times the 4 times the 5, I get 3 times 4 is 12, times 5 is 60. So I know then that 60 is going to be a common denominator for each of those. And once we have the 60, then you can go back to each one of those fractions and say, well, how do I get to 60? So 3 times what gives me 60? 20, nice. So if 3 times 20 would get me down to the 60, I could do 2 times 20 to get an equivalent to equal fraction. So 2 times 20 is 40. Nice. So that first one is the same as 40 over 60. And try to make my 40 look a little better. The second one then, 4 times what gives me 60? Well, half of 60 is 30. Half of that is 15. Or you could always take your calculator and do 60 divided by 4. You get 15. So then I'd have to do 3 times 15, 45. So that second fraction is a little bit bigger. And now the last one, if we have the 5 times, nice, 12, gives me 60. So 3 times 12 is 36. Now it's a whole lot more clear what's the largest fraction, the smallest fraction. So we could just take and rewrite them as my smallest is going to be this one. So 36 over 60 is my smallest one. My next smallest then would be 40 over 60. And my largest is the 45 out of 60. Kind of like if you have some ginormous pizza cut into 60 slices. If you get 36, you get the least amount. 40 slices, you get the next highest amount. And 45. Does that make sense? Comparing fractions? The next one, the other way to do it, so we had letter A as fractions. I want to jump and say letter B. So comparing things. But B is going to be as decimals. And if you can do a whole bunch of fractions of decimals in your head. Alright, so if you want to take and change a fraction to a decimal, so to do a fraction, to convert a fraction into a decimal, you just divide. I tried shortening up, maybe that makes it less clear, but in other words, if you have like 1/3, you want to see what it is as a decimal, take your calculator or longhand, do 1 divided by 3. You just do the division. So I'm going to take and say, write these numbers in increasing order. This will be our last example. So write these in increasing order. So in other words, we're going from smallest to largest. And this is the most similar, I think, to what we've seen in those last couple RTI tests, which maybe you don't remember, but I've had to grade all of them, so I remember them well. We have negative 0.3. So 0.3, comma, negative 1/3, comma, 0, comma, negative 0.3, comma, 1/4, comma, 1/3. So we have 6 numbers there. We want to write them in order. So if we were to take and change them to a decimal first, I'm maybe going to try to spread them out a little bit more. So I had my 0.3, that's this one there. Negative 1/3. Anybody tell me what negative 1/3 is? Go for it. Nice. So negative 0.3 repeating. So in other words, that's negative 0.3333333. You might, writing it out like that might help it make a little bit more sense soon. Then we had our 0. We had our negative 0.3. 1/4 is the same as point. Nice, 2.5. And then 1/3 is 0.3 repeating. Very good, very good. Now once we have those, some people are good at just throwing them all in order, and there's nothing wrong with that. What I'm going to kind of do is look, and I have 2 negatives. So I'm going to say, all right, I have this negative and this negative. What's more negative? Is negative 0.3333 or negative 0.3? Which one's further from 0 to the left on like a number line? Negative 0.3 repeating, because this is kind of like a negative 0.30, so this is a more negative. So my furthest one down then is going to be my negative 0.3 repeating. And once I have that done, I'm just going to cross it out, make it easier to find my other numbers. My only other negative is a negative 0.3, so that has to be next. Still with me? Now I have 3 positives and a 0, so the next one has to be, but that's still a positive 0.3. So 0 has to be next. For me, I'm kind of thinking number line as I do these. Let me make a little bit more space. I'm kind of like thinking like a ginormous number line. And we have a 0 here in the middle. We have negatives on the left. We have positives on the right. And you're looking at what's the smallest number, what's closest to 0, for those. Okay, so let me cross out my 0. Now I have 0.25, 0.3, and 0.3 repeating. Next largest is going to be 0.25, because it's 0.2. It's going to be smaller than anything that's 0.3. So 0.25. Just save my 5. 0.25. All right, and then we only have 2 left to go. So 0.3 and 0.3 repeating. Yep. 0.3 would be next. That's the same as 0.30. And then last but not least, 0.3 repeating. So that would be the putting them in order. If that seems a little bit confusing, keep the answers close by as you try doing these, and do one in the homework, check your answer, like, ooh, I got it wrong, and try to figure out, well, why is their answer right? And then go on and try the next one and kind of learn as you go that way. I think that would help you. So.